Hey guys, this is the first video of chapter 3, so this is section 3.1. A lot of vocab in this section. Some you probably know, others I'm sure you don't know, but it is mainly vocab. So let's start here. Parallel lines, which hopefully you guys know what parallel lines are, but they're two lines that are coplanar, but they never intersect. Okay, so if they're extended on and on and on, they would never intersect. In algebra, you learn that they have the same slope, and that'll come back in section 5 of this chapter. Okay, skew lines, kind of like parallel lines, kind of not. They are lines that are not coplanar, so that's the difference. But they also never intersect. Okay, so the difference in parallel lines and skew lines, or parallel lines are coplanar, skew lines are not. And we'll do some examples here in a minute where you'll be able to see the difference between them a little bit better. Coincident lines, these are two lines that lie directly on top of each other. Okay, so maybe you have a line here, and then maybe you have a line here right on top of it, okay? Parallel lines again. Oh, parallel planes. Parallel planes are two planes that never intersect. And once again, we'll see an example here in a minute. And then a transversal is just a line that cuts or intersects a minimum of two other lines. Okay, most of the time, or a lot of the time, a transversal cuts more than two, but at least two. All right, so just a real quick example. These are parallel lines, okay? They're two lines. Notice in a diagram, if you're given that two lines are parallel, see these little arrows right here and right here? They're the same arrows, so that's what tells us that they are parallel. And they have no points of intersection, okay? Intersecting lines here, remember two lines intersect at a point, so they have 1 point of intersection. Now here's coincident lines, so here's one line, and I know it's hard to see, but here's the other that's right on top of it, okay? That's what coincident lines are. So they would have an infinite number of intersecting points because it's one on top of the other, so every point on each one is shared with the other. All right, so here we're given a figure, and we want to say if lines are parallel, coincident, or skew, or intersecting, but I think if they're intersecting, they're perpendicular, but we'll see here in a minute. All right, so it says lines AB, so AB is here, and BC is here, okay? Well, this is a right rectangular prism, which means this is a 90 degrees. So these would be intersecting lines, but rather than writing intersecting, I'm going to write their perpendicular lines. So I'm just going to put this symbol. They are perpendicular, and I know that because angle B, which is the point of intersection, is a right angle. All right, now, let me get rid of this. Now, AD, so line AD is right here, and line BC, which is right here, okay? Well, notice that both of these lines are on this plane right here, so like the top part of the box, if you will. So because they are coplanar, and they would never intersect, we would call these parallel lines. Now, guys, the symbol for parallel is like this. It's like two sideways lowercase l, so I'm just going to put that there, parallel. Because they are coplanar, but never intersect. Okay, so they can go on and on and on, and they would still never intersect. And once again, this is parallel. All right, now let's do another example. So EI is right here, and we're talking about the line, so we're talking about this whole line. So EI and IH, so we're talking about this whole line too. Okay, this would be an example of coincident lines. They're the same line, different name. Okay, now let's move on to D. So we have BF, which is right here, and EH, which is right here. Okay, these two lines will never intersect. So now we need to ask ourselves, are they coplanar or are they not? Because if they are coplanar, then they're parallel. If they're not, then they're skew. Okay, these do not lie on the same plane, so this would be an example of a skew pair of lines. Why? Because they're not coplanar and they never intersect. Okay. All right, now part E, EF, which is right here, and CG, which is right here. What kind of lines are these? These are also skew lines for the same reason above. So I'm just going to put quotes. All right, last one. Line AB. So line AB is here. And line GH, which is right here. Now this one's kind of tricky. Okay. Could we say that these lie on the same plane if we were to draw this diagonal here? Okay, so those are coplanar. You have to kind of look, read between the lines. They are coplanar, but they would never intersect. So those would be parallel lines. And I'm just going to put the symbol again because they're coplanar, but never intersect. All right, now let's look at this diagram. This is kind of same but different. Now we're going to have to name certain lines or certain planes given the description. All right, so part A, it says lines parallel to CD. So we want it parallel to CD. So here's CD. And contains point A. Okay, there's only one line that'd be parallel to CD that has point A, and it would be right here. So I could write AB or BA. Okay, on B, it says line or lines that are skew to CD. So once again, we're talking about CD that contain point A. Okay, so we want them skew, so we're not going to be coplanar. So that would give us AH would be one. And also AG would be another. Okay, so part C says it's perpendicular to CD and contains point A. Okay, well the only thing perpendicular to CD and contains A would be this line right here, which would be AD. Okay, last but not least, part D. It says a plane that is, or a plane that's parallel to plane EFG. So EFG would be this plane right here. So it's parallel to this plane, and it contains point A. Guys, wouldn't that be this plane right here? So I could say plane, and there's several ways you can name this. I'm just going to say plane ABC. All right, guys, I skipped a slide that has two postulates on it. So make sure you read those and understand them. They're very easy to understand. We're not going to use them a whole lot, but you do need to know they exist and you need to understand why they exist. All right, so let's look at example 4. It says, the given line markings show how the roads in a town are related to one another. Okay, so we're going to make use of the line markings. So name a pair of parallel lines. So once again, see these two arrows here? We need to find like two arrows, which would be right here. And that tells me that these two are parallel. So I can say line DM and line FE are parallel. And notice DM, you can name it a couple. Well, you can name it DM or MD. And then EM, or sorry, EF or FE here. So B says name a pair of perpendicular lines. Okay, well now we're talking about perpendicular. So you need to ask yourself what perpendicular means. So remember that perpendicular means that they cross at a 90-degree angle. Well, the only 90-degree angle we see here is right here. So that means this line and this line are perpendicular. So I could say DM, and I'm going to use the symbol, is perpendicular to BM. Okay, now part C, it says, is FE, which is right here, parallel to AC, which is right here. Okay, well, the answer here would be no, it's not. Now, if you look on here, they are coplanar, and they don't intersect on this, but if we were to extend this out and extend this out, they would eventually intersect. Okay, so I'm going to say no, because if extended, they would intersect. All right, so guys, these are angle pairs here, and these are very, very, very important. So this is when we have two lines, and then we have a transversal. So these transversals are just called T. Okay, so there's 4 of these. The first one is corresponding angles. Okay, so corresponding angles have the same corresponding position. So notice 2 is like upper right in this intersection, and then 6 is also upper right in this intersection. So I can say that angle 2 and angle 6 are corresponding angles. Okay, alternate interior. Okay, alternate means they lie on opposite sides of the transversal. So one's over on the right, one's over on the left. And interior means they're between these two lines. Okay, so in this case, I can say angle 4 and angle 5 are alternate interior angles. Okay, back here, alternate exterior angles. So once again, alternate means opposite sides of the transversal. Okay, so one's on the left, one's on the right. And exterior means they are outside or on the exterior of these two lines. So angle 1 and angle 8 are alternate exterior angles. Okay, last but not least, consecutive interior. So consecutive, a lot of books would also call this same side. Okay, that means they're on the same side of the transversal. So either both on the left or both have to right on the right. And interior, once again, means between these two lines. So I can say angle 3 and angle 5 are consecutive interior angles. All right, so using those examples we just looked at, those 4 different kinds, I want you to go through and try to do these on your own, and then I'll go over them. All right, so notice corresponding angles, guys, they're in the same corresponding positions. So 1 is in the top left and 5 is in the top left. So I can say angle 1, angle 5. 3 is in the bottom left, 7 is in the bottom left. So I can say angle 3 and angle 7. Then I have 2 is in the top right and 6 is in the top right. So angle 2 and angle 6. And then I can say 4 is in the bottom right and 8 is in the bottom right. So I could say angle 4 and angle 8. All right, now alternate interiors. So alternate means they're on opposite sides of the transversal. So one's above, one's below. And interior means they're between these two lines. So 5 and 4. And then angle 2 and 7. Alternate exterior, guys, same thing. So 1 and 8. And angle 3 and 6. And then consecutive interior would be 4 and 7. and 2 and 5.